Hi everyone, welcome to our science briefing on subject-based banding. I will be sharing on the following. Firstly, I'll be sharing with you about the new primary science syllabus which was rolled out in 2023. This will help you get a clear idea on what your children are learning and why they are learning science. We will also talk about how they are assessed for their understanding in science. Finally, I will share with you on how you can support your children in their science learning. Now, before we start, it is important that you're aware and understand the revised science curriculum framework. If you look at the center of the circle, it captures the goal of science education in Singapore, which is science for life and society. Now, we want our students to be scientifically literate so that they can make informed decisions and take responsible actions in their daily lives. We also want to provide them with strong science fundamentals for them to innovate and pursue STEM for future learning and work. Now, surrounding the center circle are the three INS, which form the vision for science education. Students should be inspired by science, they should inquire like scientists, and they should innovate using science. If you look at the outer ring, these represent the domains that make up the strong science fundamentals. We talk about the core ideas of science. These would be the content knowledge that the students would be learning, the practices of science, the skills and the procedures they will be acquiring for scientific inquiry, and the values and ethics and attitudes that they should be developing. Okay, beyond learning the core ideas, the new curriculum also focuses on the practices of science. Now, these practices serve to highlight that science is more than just learning concepts. It is also a way of thinking and doing. They emphasize the development of skills and procedures needed for scientific inquiry. Now, this allows students to think about science and practice science like scientists. For example, students should acquire skills needed for carrying their own scientific investigations. They should be able to craft their research questions, design their investigations, conduct their experiments, and gather results and analyze these results. Now, the acquisition of these skills will be tested in application questions. I will explain further later. Now, remember we talked about the core ideas in science, which are your big concepts that the students will be learning. So the core ideas are grouped into 5 themes: diversity, cycles, systems, interactions, and energy. Now, these themes represent the big ideas in science and allow students to draw connections between life sciences and physical science. Students learn various topics across both life science and physical sciences within a theme. For example, under the theme of diversity, your children will learn about the diversity of living things and materials around them, and also how to classify them. These allow students to see diversity in the context of living things, which is the life sciences, and materials, which is the physical sciences. Now, the syllabus is also designed in a spiral manner from P3 to P6, where students develop their concepts and skills in greater breadth and depth from P3 to P6. Now, this table shows you the topics that your children would have covered by the end of primary 4. Let's move on to assessment. Now, assessment is an integral part of teaching and learning, allowing the teachers, parents, and the school to gather information on the students' progress and to work together in better enhancing the students' learning. It allows us to identify the learning gaps students may have and how we may better support them. For primary 4, the end of year exam consists of one written paper with 2 booklets, A and B. Booklet A comprises 30 MCQ questions, where each question will be awarded 2 marks, totaling to 60 marks. Booklet B comprises 14 structured and open-ended questions, where each question is awarded between 2 to 3 marks, totaling 40 marks. Students will have 1 hour and 45 minutes to complete the entire paper. Subject-based banding exercise allows students to take subjects at levels appropriate to their progress in these subjects. Hence, in a science SBB paper, 30% of the mark comprises of basic questions. Basic questions are simple and straightforward in their nature to assess students' understanding of basic concepts. They require students to recall what they have learned. Let me bring you through some examples of basic questions. Okay, here is an example of a basic question. Now, for this question, students just need to recall the properties of materials that they have learned. They just have to identify that paper is made of a material that is not waterproof. Okay, here's an example of a basic structured question. For this question, students just need to recall the stages in the life cycle of a butterfly. They just need to be able to state that M is the larva stage and N is the pupa stage. For some of these questions, helping words may also be provided. Next, we have knowledge with understanding questions. For these questions, students need to show understanding of science concepts and skills. Okay, let me bring you through some examples on knowledge with understanding questions. So let's take a look at this question over here. Students have to study the two groups of objects and identify the correct headings. For this, they need to be able to recall the properties of materials and identify the correct headings. So for this question, which is an open-ended question for knowledge with understanding, students need to be able to use their knowledge that insects have 3 body parts, 6 legs and 2 feelers to be able to identify animal G as an insect. For application questions, students need to show that they can apply the concepts and skills learned in new situations. This is also where students' understanding of the practices of science is tested. Now, this question is an example of an application question. In this question, they are describing an investigation to measure the absorbency of 4 materials. They have also shared the results. Students have to read and understand the experiment. They should be able to analyze the results given on the absorbency of the materials. Analyzing results is a skill under ways of thinking and doing, one of the practices of science. They then must use their analysis from the results and their understanding of the function of a mob to select B as the answer. This is an open-ended application question. In this question, students should be able to understand the experimental design. They should be able to identify the aim of the experiment, which in this case is to find out if children infected with malaria are more attractive to mosquito A due to a certain smell they produce. In part 1, we are testing students' ability to formulate a hypothesis. In part 2, they must explain how they can go about getting more accurate results. Both of these are skills associated with designing investigations from ways of thinking and doing. We have gone through the different examples of basic knowledge with understanding and application questions. Let me now share with you the various strategies taught to the students on answering questions. For open-ended questions, here are some strategies suggested. Students need to identify the question word. These words guide on how detailed our answers should be. For example, questions with the following terms: state, identify, list, etc. require students to give short and direct answers without explanations. Questions with the following terms: explain why, infer, describe, etc. requires longer answers with more details and scientific reasoning. We have also taught students to use CER strategy when answering questions that require explanations. Here's an example on how CER could be used. Now, if you take a look at this question, they have provided us with results on the temperature of water in a container after 15 minutes. They want to know which material, X or Y, should Zien pick to make the tube of the water heater to heat the water in beaker B faster. Now here, students need to make a claim as to what they think their answer would be. So in this case, students may make a claim that it's material X. They then have to state the evidence, which can be obtained by analyzing the results in the table. For example, from this table, we are able to tell that the temperature of water is lower in material X after 15 minutes. And they then have to connect the reasoning with connect the claim with the evidence using a scientific concepts they have learned. So for example, here their reasoning could be, therefore, heat would flow from the surroundings to the water faster. Now, let me share with you some of our observations. We find that students sometimes lack precision and accuracy in their answers. So if you take a look at this question here, for example, they have to explain why bubbles were seen coming out of hole A when the submarine was pushed into the container of water. Now we find that sometimes students will answer, they can say the air escapes from hole A and then water enters from hole B to take the space previously occupied by the air. But a lot of times students will just say air escapes from one hole and then water enters through the other hole. They never mention which hole they are talking about. So they need to be very precise in their answer by stating that air is coming in from hole A and water is coming in from hole B. Okay. Another common mistake is students do not show comparison. Okay, take a look at this question. For example, here, based on the diagram above, which greenhouse A or B is cooler on a hot day? Using a property of air, explain why. Now, students need to say that it's greenhouse B because it has a thicker airspace. A lot of times, students will just say that it has a thick airspace, so less heat would flow or less heat would flow from the surrounding greenhouse. So they need to be able to do a comparison to show us that the difference between greenhouse A and B is that A has a thicker airspace. Here are some ways you can support your child in their science learning. Okay, you can develop the love of science in your child by encouraging them to ask questions and relate science concepts to daily phenomena. You can also strengthen your child's conceptual understanding by supporting your child to do the following. Revise primary 3 and 4 topics. You can get them to organize their notes using mind maps. You can also get them to use the scientific language associated to explain science concepts. Go through questions in activity books, topical worksheets, and exam practice papers. Attempting a practice paper within the stipulated time is also good practice for them so that they learn to complete their paper within the given time. Do allow them to carry out scientific investigations at home and discuss their results with them so that this will get them into the habit of thinking and behaving like a scientist. Thank you, parents. If you have any further queries, you may consult your child's science teachers. Thank you.